Hi guys, we're going to go ahead and cover today how to finish these rational functions here that we have been graphing. I already covered how to simplify what point discontinuity is, vertical asymptotes, horizontal asymptotes, but the only kind of horizontal asymptote I did not cover, something that's not even a horizontal asymptote, which is going to be the slant asymptote. So today I'm going to talk about that one right there. It's a little bit of a weirdo. And notice that this happens when something is top heavy, okay? So when it's top heavy, then you could possibly have a slant asymptote, okay? So I'm going to cover that today, and then we're going to go ahead and we're going to graph our functions, and we're going to talk about limits, okay? And the limits usually have to do with your, actually they always have to do with your horizontal asymptote, okay? So those kind of go hand in hand. So going down here, example number 1, now you'll have to forgive me, I'm using some notes I hand wrote and copied and pasted, and you'll see later on it gets a little wild and woolly. So anyway, so let's talk about this right here. So if we go to graph this, let's just go for it. First thing, it looks like the biggest number I have out of all of these is a -4. So what I want to do then is I want to make sure that, there we go, to erase. I want to go out probably like 5, maybe 6, I don't know. 1, 2, 3, 4, 5, 6. There we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That was nice and boring. So, all right, let's keep going here. So the x-intercept's -4, 0. So we're going to go to -4, 0, and we are popping a dot on there. Then our y-intercept is 0, 2. So we go to 0, 2, and we pop a dot on there. And the next thing is our vertical asymptote. Okay, things cannot pass a vertical asymptote, and it says x equals -2. So what we're going to do is we're going to do a dotted line right through there. Okay, and then we have a horizontal asymptote of 1. Now, since sometimes these go through horizontal asymptotes, I'm not actually going to dot it all the way across, okay? I'm going to dot it at the end because horizontal asymptotes predict end behavior, okay? So y equals 1 is right here, but what I usually do is I just do like a light dot and then I do this at the end, okay? So that's how I do it. Every teacher's a little different. That's how I do it, okay? It's going to predict our end behavior. So let's look at what we got going on here. So we have some kind of function over here, okay? Obviously, it's trapped because of the vertical asymptote, and its end behavior should approach this right here, okay? So we can go ahead and we can assume that looks like this. Oh, and there's one thing I like to do with my vertical asymptotes here. I like to say if they're even or odd because that tells me if it's going to go the opposite way or the same way, okay? So it does say over here that for my vertical asymptote it was odd, okay? So it's going to go opposite ways. Let me go ahead and write odd here. There we go. So we know that this guy is going to start up this way, and its end behavior is that it's going to approach this right here. Okay, so this one's kind of an easy peasy one. Hopefully not too bad for you. So that's what this graph's going to look like. Well, let's talk about the limits. So as x approaches infinity, as x goes on and on and on and on and on, what's the y value getting closer and closer to? Well, the y value is not going to infinity, which is what some students say, because it'd be going way up here, right? It's not doing that. It's actually going this way, and it's getting closer and closer and closer to 1. And then going over here, as x approaches negative infinity, what's it getting closer to? On the y-axis of 1. Okay, so the horizontal asymptote kind of goes hand in hand here with your limits, okay? So kind of like look at those when you're doing it and match those up. And when we get to slant asymptotes, I'll talk a little bit more about those. So let's go down here to number 2. On number 2, looks like to me that the biggest number we got going on here is a 3. So I'm going to go out 1, 2, 3, 4, 5, okay? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So on here, our x-intercept is -2, 0. So go ahead and pop a dot on that -2, 0. Our y-intercept is 0, 2, 9. So just do the best you can on this one. I'm going to say it's right about there. Our vertical asymptote is x equals 3. So I go to x equals 3, and I go ahead and I do that dotted or dashed line. And it says it's even. So they'll go in the same direction. And I actually like to kind of jot that down, even. Okay? So even goes in the same direction, and then horizontal asymptote is y equals 0. And remember, I like to just kind of make it float out here So I'm going to do this, just make it kind of dark right here at the end. So our end behavior is going to approach 0. There we go. Okay, so what is going on here? This one's goofy, right? Because, like, look over here. We have an x-intercept here, yet we know it approaches 0 at the end, right? Your little tail, your little arrow better be getting close to this guy here. But look, there's a dot here. So here's what must be going on. It must be doing this, going through this dot, but then it needs to, like, come back up here. It kind of snugs back up to that line there, okay? It kind of snugs back up. Now this says even, right? So even means they are going in the same direction. So over here, there must be this, and it should approach the dotted line. Now I know it doesn't go through and approach it, right? Or I'd have an x-intercept. I don't have an x-intercept here, so I'm trapped. Okay, trapped in here. So this is what your graph will look like. Now let's talk about the limit. So what happens as x goes further and further out, gets to infinity? So this is what's happening. What's happening to the y value? What is your y value approaching? On the y-axis, we're approaching 0. And then over here, same deal. As this goes further and further out, it's getting closer and closer to what y value? 0. And remember what I said, horizontal asymptote and limits, aka the end behavior, go hand in hand. So you want to use those together. Use those together. So let's move down here. Let's look at example number 3. So on example 3, the biggest number I'm seeing here is a -4. So let's go 1, 2, 3, 4, 5, I don't know, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So just putting some marks out there. So first I'm going to apply as my x-intercept, which is 2, 0. So at 2, 0, put a dot, your x-intercept. I do want to note here, I haven't been writing it up here, but you notice that all these x-intercepts were odd and they go through. So on this one here, I'm noticing that it's going to have a little bit of a bounce right there. So it's going to bounce off of that x-intercept. My y-intercept here is 0, -2. So we'll put that right there. And then vertical asymptote, there's 2 of them. So one at x equals -4. So put a dashed line at x equals -4. And please put a dashed line at x equals 1. So we have something that looks like this. Looks kind of weird and goofy. Let's go ahead and take care of this horizontal asymptote. So remember, the horizontal asymptote, it can cross if it wants to. So I kind of just do a dotted thing there and travel along like this. There we go. Alright, so we have something going on like this. And then for the vertical asymptotes, they were both odd, so they'll go in the opposite direction. So odd and odd. Alright, well, let's see. What are we working with here? So I am noticing this right here. Let's look at this dot right here. What do we do with this? Well, it doesn't go through the x-axis, right? Or it would have an x-intercept here. So it must stay within these boundaries. It must stay within these boundaries. So I guess it would be going like this then somehow. There we go, right? Because it can't go through the x-axis, so it must come right back down over here. Well, if this guy is going downward, then this one must be going upward because this is an odd asymptote. So this guy must be going like this. Now this is weird. It has to bounce here. Remember we talked about that. It bounces. Well, but that's not too weird if you think about it, because what's the end behavior supposed to be? It's supposed to be approaching this right here. So it kind of bounces off it, and then it starts its approach. Okay? Looks kind of freaky deaky, but that's how it's supposed to look. So this is also an odd asymptote. So again, this should be up here, and this guy must just snug up to this. Alright? So let's fill in our limits. Now remember, our limits and our horizontal asymptotes kind of go together. So as this approaches infinity, what y value does it approach? It's getting closer and closer to 2. And on the on the left-hand side, as this approaches negative infinity, what y value does it get closer and closer to? 2. Okay, so your limits, hopefully you're seeing that they kind of match up with your horizontal asymptote, right? Okay, so let's keep going. Let's talk about example 5, because I skipped example 4 in your notes. So on example 5, biggest number I'm seeing here is a 3 and a -3. So ooh, we have a hole on this one too. We haven't done that yet. So let's go ahead and let's go out at least a 4. 1, 2, 3, 4. I'll do 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now later on you're going to have to go out to like 10 or something. So it is important to kind of like look and see what are you going to be doing. So let's go ahead and plot the whole. So it's at -1, -2, and you can put a open dot there, that's your whole. And then we have a vertical asymptote of x equals -3. So put a dashed line there. And I did make a note that it is odd, so we'll go in opposite directions. We have a horizontal asymptote at y equals 1. So I'm going to put some dots there and then do my dashed line at the end. So our end behavior, it's going to approach y equals 1. Then we have an x-intercept at 3, 0, and it is odd, so it will go through this x-intercept right here. Then we have a y-intercept of -1. Okay, so you should have all this on your paper. So let's see what's going on here. Well, let's go with what's going on with the dots, right? So what looks like to me that it's going to be approaching it this way, so let's just go ahead and jot that in there. It's going to hit that right there, that hole. And then it goes down like this. Now this is odd, right? So that means if this one's ending going downward, this one will end going upward over here. And you can see where I accidentally kind of cut and pasted right there. So you got a guy that looks like this. So I mean that's it right there. So your limit should match your horizontal asymptote. So as this goes to infinity, it's getting closer and closer to y equals 1. And as this goes to -infinity, it's getting closer and closer to y equals -1. I'm sorry, y equals 1 again. All right, so these two are both going to be 1. All right, let's see what we got going on next here. Okay, so down here on this one, it looks like our biggest number here is 3. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so what I'm going to do here is first plot the whole. So -1, +2, boom. Then I am going to put my x-intercept, which is 1, 0, and it is going to bounce. It says it's going to bounce. My y-intercept is 0, 2 ninths, so, whoops, put that in the wrong spot there. 0, 2 ninths is about there. Good enough. Kind of wing it. Vertical asymptote is x equals -3, and it also said it's going to be even, so they're going to end in the same direction. So there we go, even. And horizontal asymptote is y equals 2, so dotted up, and behavior. Dotted up, and behavior. Okay, cool. So let's graph it, and I'm seeing some dots here, right? So this is weird looking, right? It's okay. Well, we know this x-intercept here is supposed to be a bounce, right? So let's bounce it. And then we know our end behavior is supposed to approach this 2 here. So we might as well just connect these dots, and we could assume that's what it's going to look like. Some weirdo, goofy, strange looking thing like that. Okay, so that's what we have there. And then let's see if this is even here, if this one's even, so that means they end the same direction, right? So this guy must go bloop, just like that. Right? Now our end behavior is 2, right? It's approaching 2 and approaching 2. Hopefully those limits are getting really easy for you now, and you're seeing how the horizontal asymptote is directly involved with your end behavior. Okay, so I know that you had to watch a video on this in class today, so here's what I'm going to do. What I would like you to do is in your homework on your worksheet, I would like you to go ahead and I would like you to finish up the graphing and the limits on all of the problems except for problem 9 and 10. So for now, skip 9 and 10 on your worksheet. 9 and 10, you can go ahead and skip, okay? The rest of them, can you finish up the graphs and can you finish up the limits? So the rest, finish up the graphs and the limits, but skip 9 and 10. And if I went too fast on this video, what I'm going to do is I'm going to save it, and I'll go ahead and I'll upload it to Canvas as day number 2, okay? So 3.7 day 2. I will upload this exact file to Canvas, and then you can look at it, and if you missed anything, you got it right there. And I'll also go ahead and link this video in case you want to watch the video again. All right, so thanks for being great for the sub. See you when I get back to class. Go ahead and work on that worksheet right now. Bye-bye.